Hello, welcome back. In this segment, I want to discuss an interesting reverse engineering problem. It's a small problem. Let's get started. Suppose you're given a fragment of C code, okay, where star P equal to D, return X minus C, okay. The question is, we need to reverse engineer the signature of the function or prototype of the function. We don't have the prototype here, right? You only have assembly code here, okay. And the goal is to reconstruct the signature of the function based on the assembly code and these two lines of C code. All right, now how do we do that? Reverse engineering is a bit tricky. It's not necessarily well structured in general. You can go in many directions, but we can go through this exercise. Here we are saying return X minus C. This is a subtraction. Sub means subtraction. And this is AT&T syntax, so this is the destination. EDX is subtracted from EDX with AX. So this really means EDX is equal to EDX minus EAX. Okay, so let's look at where is EDX coming from. EDX is coming from 20 plus EBB. 20 plus EBB means the fourth argument. Okay, if I were to write the syntax of this function, fun, it is returning an integer, X minus C. We will find out that in a moment. Okay, so fun is the function, and if you look at the number of arguments, very likely as 4 arguments, because we see only until 20 EBB, we don't see 24 or 28. So 20 means 4 arguments. If you remember the number of arguments, you have EBB, right? It's a base frame pointer. EBB plus 4 is the return address. Okay, EBB plus 8 is the first argument. EBB plus 12 is the second argument. Therefore, EBB plus 20 must be the fourth argument. Okay, so we have 4 arguments. We don't know what type of arguments are there, but we can conclude here the fourth argument must be an integer, because we see a move L. L stands for long type, so it's integer type, and the EDX must be X. So we solved that problem. All right, and we are subtracting with EAX. EAX is C. Okay, where is EAX here? EAX is 8 plus EBB, which is the first argument. But we have SW. Okay, S means sign, W means short. So it is short. Okay, this is a short type, short C. Okay, so the first argument is of type short. Okay, short C. We're done with that. And now we can look at some more things. We are seeing here move SLBL. B means byte. 12 plus EBB means the second argument. So second argument is moved to EDX. Okay. And therefore, the second argument is here. Okay. We already figured out X and C. Second argument is moved to EDX. And third argument is moved to EAX. Okay. What are we doing here? We are saying take the value of EDX and put it into, we are taking EDX and putting it into EAX, memory reference by EAX. Okay, that means the third argument must be a pointer because of the memory reference here. That means the third argument is integer star P. Okay, so we found out the third argument is integer star P. All right, so in the place where P points to, we are going to copy the value of EDX, which is the second argument, but it's B. B means byte, which is the character type, so it must be the value D. Okay, so short C is the first argument, character D is the second argument. So this is the function signature. Okay, so we solve the problem. P is, of course, integer pointer into pointer type, right? We can also see it in the C code fragment they gave us. And D is a character type. X is an integer type, and C is a short type. Okay, so we found all the types and the actual signature. Okay, this is how we could, given a fragment of C code and the corresponding assembly code, we can reconstruct the prototype of the function. Okay, as you can see, it's not necessarily well structured. This is how reverse engineering is, of course. We try to find some patterns and very quickly try to go and leverage the pattern. In this case, the subtraction is the key and the pointer reference is another important clue, then we can reconstruct this prototype. That's all. Thank you very much for your attention.